Section 9.7, Day 1, Graphs of Polar Equations. So the other day we looked at how to convert nope, that's not. Section 9.7, Day 1, Graphs of Polar Equations. The other day we looked at converting from polar form to rectangular form. We're going to do the same thing today, but then we're also going to graph the new equation. So let's take a look. Example 1a, r is equal to 6. So remember the other day we talked about a couple different techniques to change polar to rectangular. And one of those ways was to square both sides of the equation. So if we square both sides, we get r squared is equal to 36, knowing that r squared is equal to x squared plus y squared. We can identify this as a circle with a center located at 0, 0, and the radius equal to 6. So to graph this on the polar coordinate, we know the radius is 6, so 1, 2, 3, 4, 5, 6. And you can do that in all four directions, but since we're on the polar form, you can see where 6 is located. And then the center is at the pole, so then you just need to graph that circle the best you can. And so to make sure that we answered the question, it says describe the graph of each polar equation, and we did that. It's a circle centered at 0, 0, the radius is 6, and then we also graphed it. And here is the new equation in rectangular form. So those are all the things that are being asked. Example 1b, r sine of theta is equal to 4. Once again, going back to our previous lesson, what do we need to do here? Well, what's r sine of theta? R sine of theta is equivalent to the y value, so y is equal to 4. What do we know about a rectangular equation y equals 4? We know it is a horizontal. So it's a horizontal line going through y equals 4, so 1, 2, 3, 4. So then we will graph that line. And then once again, here's your equation in rectangular form. Here is the description and then the graph itself. So in example 2, there's two more equations here. What I want you to do is I want you to pause the video and go ahead and convert these to rectangular form. These are two equations that we talked about the other day where we converted polar to rectangular. So once again, pause the video, at least write them in rectangular form, and then we'll talk about the graph as well. Alright, so in 2a, we can write it as tangent of theta is equal to tangent 5 pi over 6. Tangent of theta is equivalent to the ratio y over x. Tangent of 5 pi over 6 is square root of 3 over 3, and that's actually negative. And so y is equal to negative square root of 3 over 3x. And so it's going to be a line through 5 pi over 6, that angle. So remember, here's pi over 6, so this would be 5 pi over 6, so we're just going to draw a line going through that angle. And so here's our equation in rectangular form. Here is the description, and then once again the line going through 5 pi over 6. Alright, example 2b, r is equal to 3 secant of theta. Remember, we can rewrite this as 3 divided by cosine of theta. Multiply both sides by cosine of theta to get r cosine of theta is equal to 3. And r cosine of theta is equal to x, so x is equal to 3 is the equation. The description of that would be a vertical line, and that vertical line will be going through 3 units from the pole to the right. And there you go. So there's another 2 example where one, we have a diagonal line going through an angle of 5 pi over 6, and then the other one a vertical line going through x equals 3. Alright, here's 2 more examples. I'm going to go through 3a with you, and then I'd like you to try 3b on your own. So r is equal to 4 sine of theta. Once again, we did this the other day by multiplying by r to both sides. That creates that r squared, but it also creates r sine of theta. So we can rewrite this as x squared plus y squared is equal to 4y. We know this is a circle, so we're going to set it up so we can complete the square. Take half of -4 is -2. -2 squared is 4. So we recognize this as a circle centered at 0, 2 with a radius of 2. So from the center 0, 2, so x would be 0, y would be 2. So here's your center of the circle, which on a polar graph makes it a little bit more difficult because it's not centered at the pole. But then you'll count 2 units up, 2 units down, and then 2 units to the left and right, which is kind of hard because you got to kind of look back down at your polar axis there and just kind of eyeball it as to where that should go. Same thing on the left hand side, and hopefully we'll see how it works out here. So we have our equation, our description, and then once again the graph of the circle. So why don't you go ahead and pause the video and try to do example 3b on your own. It's very similar to the one we just did. So you can see once again, approach it the same way. Multiply r by both sides to get r squared. Change r squared to x squared plus y squared. You also get -3r cosine of theta, so change that to -3x. Add 3x to the other side, complete the square, and you get the equation x plus 3/2 quantity squared plus y squared is equal to positive 9/4. So we know it's a circle centered at -3/2, 0, with a radius of 3/2, because r squared is equal to 9/4, so then you take the square root to get 3/2. So now it's centered at -3/2, so we'll have to go to the left 1 and 1/2. So it's -3/2, but also your radius is 1.5. So we'll go back to the pole, and then we'll also go to 3 units to the left of the pole, and 1.5 from the center. So this being the center. And then we also have to once again kind of eyeball that 1.5 in terms of the square, or in terms of the value on the polar axis there, or the polar coordinate I should say, and then graph kind of the best circle you can, trying to hit all those points. And so there you go. There's another example of a circle not centered at the pole, once again with a radius of 3/2 centered at -3/2, 0. And so the last thing here is a summary, but I'm going to look at lines and circles and what you get for each of them. So I'm going to write a couple things down as we go through this and just kind of have you guys write this stuff down as well, because this is what you'll be recognizing as you go through. So in terms of lines, if you get theta is equal to an angle, you would rewrite this as tangent of theta is equal to tangent of whatever that angle of alpha is. You would rewrite tangent as y over x, and then you would multiply by x, so you get y equals whatever tangent of alpha is times x. That will represent the slope of that line, and then this will just represent positive, negative slope, whatever it is, but it'll represent the line through the angle alpha, whatever that is. Okay, so that's one example. Next one we can look at is if we just have r sine of theta is equal to a. R sine of theta is y, so y is equal to a. So this would just be a horizontal line through that value of a. So there's another example. And we could also have r cosine of alpha is equal to a, and that would just be x is equal to a. And if x is equal to a, then we have a vertical line. And so those are really the three different types of lines in terms of what your equation would look like in polar form to start, and then converting it to rectangular form. Now with circles, what do we get as an example? We could get r is equal to some value of a. That's where we would square both sides, and then convert that to rectangular to get x squared plus y squared is equal to whatever that a value is squared. That'll be centered at the origin with a radius of a. So there's one example. We could also have r equals, could be plus or minus a, doesn't matter if it's positive or negative, sine of theta. And so what we end up getting here is we would multiply both sides by r, and then convert that. So if we multiply both sides by r, you would get the r squared is equal to plus or minus ar sine of theta. And remember, r sine of theta would change to y. And so what ends up happening is change r squared to x squared plus y squared. And then r sine of theta would be y. And so when you go to complete your square, I'm not necessarily going to go through all of this, but when you go to complete your square, you will have x squared plus y squared plus or minus ay plus blank is equal to 0 plus blank. And so what it ends up coming out to be is x squared plus y plus or minus half of that a value, and then it's equal to half of the a value squared. So that would give you a radius of half of a centered at 0 comma half of a, and it could be plus or minus as well. And so I wouldn't necessarily go through and try to memorize that, but the idea is, I definitely wouldn't try to memorize it, but the idea is that if you have r equals to plus or minus a value times sine of theta, you will have a circle centered away from the pole, and you will have to complete the square to do that. And so the other version of that would be r is equal to plus or minus a cosine of theta. So I'm not going to go through the same thing, but basically what it ends up coming out to be is x plus or minus a divided by 2 squared plus y squared is equal to a divided by 2 squared. So now the center would be at plus or minus a divided by 2 comma 0, once again not centered at the pole, and then the radius value is still a divided by 2. So once again, definitely not memorizing that, but just knowing both of those scenarios and what you have to do to complete the square to make sure that you have a circle not centered at the pole on those two examples. If it's centered at the pole, it'll just look like r is equal to some angle. And so lastly, this is for you to create your own summary as to those important pieces. We kind of just did a nice one right there of all the different examples, but if there's anything else you need to add to that, please do so.